6.3 square root functions and inequalities. Let's go to this worksheet. So identify domain of each function. So remember, so domain is all about we could plug in. When we talk about square roots, the general idea is anything on the square root can't be negative. So x has to be greater than or equal to 0. So that's the general rule here. So if I want the domain of this guy, just put x is greater than or equal to 0. There's your domain. Next one, square root of x minus 4 minus 6. So again, domain's the only thing underneath the radical. So that's one thing I care about. So x minus 4 has to be greater than or equal to 0. Because again, can't take a square root of a negative number. Add 4 over, and you get that. Now, I mean, you could take a square root of a negative number, you get imaginary. We don't want imaginary for a domain. It's all about real numbers. We're using a real plane. Next one, same idea. It's the only thing underneath the radical. So 2x is greater than or equal to 0. I'm going to divide by 2. So x is greater than or equal to 0. That's my domain. So domain means, that's an ugly arrow. There we go. So remember, what could I plug into this function? What could I substitute into this function? Anything above 0, anything above 4, or equal to 4, anything above or equal to 0. Next one, let's graph the function. So you want to talk about where you start off at, just like before, inside opposite, outside follow. So my vertex, what I really call a vertex, is negative 2, 5. That's where we're starting, right? We're going left 2, up 5. Right there. And then a square root function looks kind of like a half parabola opening that way. So it looks like this. So there's my function. Domain, x values, right? What's the lowest x you see? And that's right here, which is negative 2. So we start at negative 2, and we go all the way until arrow. Remember, arrow means all real numbers. So infinity, I should say. So bracket negative 2, all the way to infinity. The range, what's the lowest I see, is right here at 5. And goes all the way for arrow. So from 5 to infinity. By the domain, you see this, right? So I got for my domain. It's the exact same thing as if I did the, like how we did in the beginning. X plus 2 is greater than or equal to 0. X is greater than negative 2. Right? These mean the exact same thing. This is called set builder notation. This is called interval notation. They mean the same thing. Right? This says everything from negative 2 to infinity. This is everything greater than or equal to negative 2 on, which would be up to infinity. So either way is fine. The next one, right, where do we start at? Inside opposite, outside follow. So 2, negative 8. So 2 and negative 8. And then, so we're right there. And then we notice there's a 4 outside, so it's a vertical stretch. So again, each way to think about it, it's like slope. It doesn't work the whole way, but it does work kind of for your first one. So I go in over 1 and up 4. So over 1 up 4 will be around here. I'm just doing a sketch. Might be 3, but it's supposed to be 4. And then this opens kind of the same way. Probably going that way. What's my domain? Domain is from lowest to highest, so negative 2 from 2 all the way to infinity. And then my range, my lowest is right here, negative 8. And you go all the way into infinity because arrows. So there's my domain, there's my range. I should do those in different colors. I don't like the fact that these are here because that's not part of the graph. Alright, so just like that. Next one, negative 1 square root of x plus rad 3. So where do we start off at? Always we want to talk about. Right, inside opposite, that's a 0. Outside follow 3. 0, 3. Now again, there is a vertical stretch. Well, it's not a stretch, but there's a vertical flip on the outside. It's like a slope of negative 1, so we're going to go down instead of up. So it's like down 1 over 1. So it's kind of like this. I mean, it keeps on going on. That's not a very good one. It keeps on going on, so I shouldn't like level off. It keeps on going lower and lower and lower, just very slowly. Well, so that's my graph. Domain starts at 0, goes all the way into infinity. I put a bracket because we do start at 0. My range, a little funky. Lowest first, arrow. So negative infinity all the way up to 3. Or infinities are narrow brackets. But you do stop at 3 sides of the bracket. So that's my domain range. Over here, a little tricky, there's a number on the inside. You can't do anything yet. You gotta factor the number out. So let's do, so my inside, it's not inside opposite because the 2's that are messing everything up. So let's factor it out. 2 x minus 2 plus 1. So now I know, okay, I'm moving right 2 and up 1. Right there. What's that to do? It's a horizontal shrink. So to make it a little shorter horizontally. So I'm gonna go stick slope. Let's go up 1/2. Again, it's just a stretch. It's just a sketch. It's not perfect. So it's kind of like that. Right, horizontal shrink. So shrunk horizontally. It's not just stretched out. My domain, we're starting at 2 going all the way up. So 2 to infinity. Bad infinity sign. My range from 1 all the way to infinity. There we go. So that's how you graph it. Next, the velocity of the roller coaster as it moves downhill is given by this. So this is my velocity. Where v is the initial velocity, so small v is the initial velocity. H is a vertical drop, so that's what h is. The designer wants the coaster to have a velocity of 90 feet per second, so that's this guy when it reaches the bottom of the hill. If the initial velocity of the coaster at the top of the hill is 10 feet per second, running towards that model situation. Okay, we have big V. Now the initial velocity is the little v, so 10 squared plus 64h. Now, how high should the designer make this hill? Well, again, I want the velocity to be 90 feet, so I'm going to plug 90 into here. So 90 equals radical, let's just simplify that, 100 plus 64h. Now, a lot of people would go, oh, this is 10 plus 8. No, it's not. Remember, this is inside stuck together. I got to get rid of the square, the radical, so I got to square everything first. So this side is 100 plus 64h, and then 90 squared. I should know this off of my head, but just to make sure, 8,100. And then subtract 100. So 8,000 equals 8,000 equals 64h divided by 64. And 8,000 divided by 64 is, give me a second, 125. So h equals 125. So it should make about 125 feet tall. Write an equation, write the square root function represented by each graph. So I gotta write the equation for this one. So again, talk about where you started, right? So let's look at this one. I'm starting here at 4 and -6. So my basic square root function is this. Like that's a generic square root function, right? Inside opposite, outside follows. This is moving left to right. That's moving up and down. So for this one, it's just be y equals x minus 4 minus 6. That'll give me this graph. Move right 4 and down 6. Same thing with this one, right? Our basic graph looks like this. And we're starting at, looks like -2 and 4. So -2 goes here and 4 goes there. So y equals square root of x plus 2 plus 4. Next one, right, that point is -6 and -6. Our general equation is this. So the -6 there, -6 there. Now there's one difference here. Notice it's opening down, so it means there's a negative on the outside. Just make the flip, so it's actually going to look like this. That's the equation, right? Negative on the outside for the flip, plus 6 on the inside because double negatives, right? Inside opposite, and then outside follow. So that'll be a graph. Graph inequalities. So these are very similar to the last ones, except now we have the shade. So let's look at the first one. Where do I start? Inside opposite, 5. Outside follow, nothing, so 0. So 5, 0. You'll notice how it's not, there's no line underneath it, so it's a dotted line. It's a normal graph. It looks like this. This is a sketch. And it's less than, looks like an L. So we're going to shade below. Now, key thing about shading below, you can't go crazy. You can't go all the way over here, right? The graph starts there, so you can't go past that marker. So acting below the graph itself, not the whole thing. Next one, greater than or equal to, so you got to actually fill it in. Where did we start? We started -3 and 0, right? Inside opposite, nothing outside. So let's start -3, 0. Notice this one has a negative on the outside. It's like a flip, right? And there's a stretch. So it's like our slope. We're going to go down 4/1. Like that. Solid line. So it's going to look kind of like that. Again, it's just a sketch. And we want above this guy. Greater than. So everything above it. And remember, just watch I don't go over here. Right, graph starts here. And it's just a sketch though, but don't go crazy. Next one, similar idea. Inside, opposite, outside, follow. So we're starting at 6, 0. And again, we're going to go upside down. Negative on the outside. So it's like a slope of -2. So we're going to go down 1 over 2. Down 2 over 1 is what I meant to say. And again, solid. And we're shading less than this time. So below this guy. So we're kind of like this. Kind of like that. Last few. Remember this one? We can't move. It's not right 12 and up 8. You gotta factor out the 4 here because there's a number in front of the x. So square root that, and you get x minus 3 plus 8. So our center is gonna be 3 and 8. Oops. 3, 8 should be here. There we go. Now what's that 4 do? That's a horizontal shrink, right? So it's a horizontal shrink of factor 4, but what does that really do? If it makes you feel better, you can actually simplify that. That's the same thing as saying 2 square root of x minus 3. And you get a vertical stretch. They're the same thing. Horizontal shrink, vertical stretch, exact same thing. So it's like a slope of 2. Go up 2 over 1. Dotted line, so it looks kind of like that. Again, this is just a sketch, but the graph looks sort of like that. And then I'm shading less than again. So shade below. Okay. Okay, the next one. Right. Center, inside, opposite, outside, follow. So -3 and 0 again. Slope of -2. Make sure we haven't done this already. So again, that's a vertical flip on -2. So down 2 over 1. And then dotted line. So it's kind of like this. This is a sketch. And we're shading less than again. So it'll be below that. Again, I can't go any further than this guy. So something like that. Last one. This one looks annoying. Let's factor that 2. Now remember, you can factor out anything. It's dividing. So -1 divided by 2 is -1/2. So I'm going to start at 1/2 and -3. 1/2 and -3 around there. Right. So then, again, it's a horizontal shrink of 2. Like if you actually took a square root, it would be like 1.37-ish. So it's like you're moving up 1.37 over 1 is what it's essentially saying. Again, we're just doing a sketch, so something to this effect. Not perfect, just a sketch. And then this is greater than, we're going to shade above it. So something to that effect. I actually went a little too far over here. It doesn't go past 0. Right, so it's like a 1/2. Oh. Anyway, that's it. That's the worksheet.